Hello everyone, I'm going to talk about the 399 evaluation division. The question is you are given an array of variable pairs equations, an array of real number values where the equations equal to a and b, right, for here, a, b, and the values I represent the equation of a, I, and divided b is equal to this value. Okay, each A or B is a string that represents a single variable. And you are also given some queries like A, B, like AC. And return the answer to all the query. If a single answer cannot be determined, return -1. And now the input is always valid, and you may assume that evaluation the query will not result in division by 0, and there's no contradiction, and the variable do not occur in the list. The equations are undefined, so the answer cannot determine for them. Okay, like this x not in this one, so we don't know even they are same. We still return the -1 here. Okay, so for this problem, it's a graph problem. You have to identify first. So like this, A pointed to the B, like AB, right? Pointed to B. Actually, this means A divided by, you can see here, A divided by B is equal to 2.0 here, and B pointed to the C here means the 3.0. We also can translate this one. If B divided by A actually is equal to this one, so which means we also can let the B point to the A, so it's minus here. It's 1 divided by 2. Same for the C here. Okay. Okay, so so this is graph problem. So when we have the A and C, so which means we actually B pointed to the 2 and product the B divided by A, B divided by C actually is equal to the A divided by C is equal to 2 times 3. Here is equal to 6. So 6 is the answer we store in the results. Right, so to search the B neighbors, whether it has the C, then we go to checking this one. If they are not find it, we actually return -1, which means we didn't find it. So let's show, it's a user DFS. So at the beginning, we can write the result first. Double for here is query size. And also for the equation, we need to use the map to store the graph. So string here, and for here we when we find the string, this one is actually means the B. String for here is the double here. Why this used? Because when you have the A, right, And you actually not just only point it to the B, but you also can point it to the C if you have something. So that's why we need to use the map to store this. So for here, use the equations, values, that's all need. Private equations, double values. Okay, this one is finished. I'm not finished, I will implement this later. So we have the graph. Now we need to follow up the query. When we find the query, so list string cur, and also we have the string dividend is equal to the queries, is equal to the cur, the first one. Divisor, get one here. For example, the first one, right? We have the, and this is the A, and this is the C. Now we have the some conditions, right? If this one, if the variable does not include the list, so which means the graph not contains key dividend, or graph not contains key divisor, then we actually can read out another, read out I is equal to the minus 1 point here 0. The another condition is they are the same. If dividend, because it's string, so equals divisor, then we return, then the results I is equal to the 1. Otherwise, we need to use the DFS to do this problem. So I need to set visit to start to do the DFS for the graph. So we need to visit it. Okay, so for here, everything finished, we return the results. Now DFS, private, I need input the graph. Graph dividend divisor and product and the result. Should I read out divisor? Visit. This is enough. the string is target, what we need to find it, and for here is double cur prod, and set a string. Okay, so if cur is equal to the target, right? So which means we finally we return cur product. Otherwise, we visited add cur. Then go to the neighbors. The graph neighbors is map. Get cur and entry site. Yeah, so for this one is for the entry set. Then what should I do is to get the neighbors, and neighbor has the string and neighbors. So we string, which means the nest. Nest is they get key, and for the double value here is they get value here, and we have to check if the we already visited. We actually don't need to do this. Which means encounter some cycles, but I don't want to visit again. So move to the next neighbors. Contains nest, which means we continue to check in the next neighbor. Otherwise, we can do the DFS. Keep searching, right? We have to use the readout to catch this. Next target product product times current value visited. And then we have to check if the results not equal to 1.0, return the results. We don't need to search. Otherwise, we need to which means we didn't find it. Yeah, for the next one here. Okay, so I think this DFS is already finished all the thing. Then return, yeah, if we return the product, yeah, we collect the results. For here, it means the result is -1, we keep continue. If not equal, which means we find one of them, so we can directly return it. Okay, so for the build graph is graph. For the equation, so we can start from the equation. Size. If, okay, so list the string cur equation gets, for example, we can get the A and B for this one. Then okay, so A, B, right? So what should we do is string dividend is equal to cur get 0 here, and string divisor cur gets 1 here. So we have to check if the graph didn't contain those of them, we have to create a new map. And graph. Okay. Okay, this one is done. Then we can put the dividend, and also we have dividends. Get dividend, put the we already have the dividend. We should get the and put the divisor another value. Divisor, put the dividend. Then everything finished, we return the graph. Okay, Paris, where the 2 divided. Oops. Okay, so -1. All the -1, okay. Okay, this one is should be good. Okay, this one should be the string should be the equals because they are string. If they are, that's why I always return the never equal. Never equal. Their reference is different. Yeah. Yep. And for the time complexity is you can see for here is query size Q, and then for the DFS, and for the DFS is all the neighbors. It's kind of like search the graph. So the graph is their kind of like a, we can treat it as a tree, right? The tree is the leaves and nodes. So the time complexity should be the Q rates time the here. And for the space is plus the E. This one, and for the DFS, all the nodes, the worst case, right? Where does the time come? Why this so slow? You can see, yeah, this is the time complexity. Therefore, here is the space complexity. Yep, thank you.